Hey, I'm Napo.
And I'm Doug, and we just got done working with a large team on a really interesting project, and we want to tell you about that journey that we took building it out. And a big piece of that challenged our assumptions about what it means to architect software, and we think that this will challenge your views too about what good software can be.
Yeah, so to start us off, I'd like you to imagine your typical N-tier application. You might have simply a display, some logic, some business logic as part of it, as well as a stateful storage, your database or something. This is actually what we had on our project for multiple years before we, this is a more simplistic view of it, but before we kind of outgrew its boots, got to the point where it was pretty difficult to keep adding on to it. So what we did is we took a scalpel to it, and we split it up into microservices in just what made sense for the application, what made sense for the business. Now, microservices are pretty great. They have benefits like they're smaller, more manageable code bases. You could have different teams working on different pieces on the different microservices. But unless you have an extremely simple application, extremely simple services, those microservices can't live in isolation. Eventually, they're going to have to start talking to each other and use each other's data, whether that's sharing a database, that's sharing their business logic, maybe calling each other, most likely calling each other, or even sharing a display, though more likely even is a combination of all of the above. So this does introduce some challenges as well. I mean, you've split what used to be one system potentially into multiple applications that need to call each other, and then you're tightly coupling these microservices. So if they require each other's data, if one goes down, you could cause cascading failures throughout your microservices.
As we were working through the challenges that microservice introduced, we were also trying to add new features to our platform. And those features had their own challenges. So first off, we wanted to make an audit trail so that we knew what happened to what data when. So that was another feature to add. We wanted to know how to build notifications between the microservices so they can react to changes with each other, and also so users could be notified of those changes. We wanted to build business intelligence so that the business can look at a time-based view of the data. When did certain things happen, and what are the trends of that data? We also needed to build out new API, read models so that different microservices can serve different purposes, read models that are updated in real time. Like a lot of teams, we were trying to explore machine learning, and a big component of that is having historic data, not just a current snapshot, but a history of data. So that's another feature we were trying to build. And to kind of round it all out, we wanted to build batch processing, so a system that can react to large loads or small loads at the same time. So we were working through all those different types of features, which would be complicated enough with one service, but then with microservices, we wanted those features to work with every microservice in the same way, simultaneously dealing with large amounts of load, variable load, scalability, resilient, performant from the bottom end. If there's more load, we can handle it all.
All right, whoa. All right, so as you can see, this is getting way too complicated. It is a maintenance nightmare. It is a development nightmare, just coordination galore. So why don't we take a step back here and let's revisit this example, these features that we were asked for, that we were trying to solve. We really need an easier way to solve these problems, as well as the communication problem between our microservices, in a way that lends itself to providing this data that is required by some of these features that the data needs to be from the system over time. So what if we flip this architecture? What if we got rid of our database and we brought those features, like that data that those features need or produce, and brought them to the core of our application, and we made that our data? That is what's going to be called, what we're going to refer to as our event storage. And it's really what is at the heart of the event-driven architecture.
Yeah, so pause on that point. This is really the innovative change here. And this isn't just a seventh feature. No, this is changing the architecture. So at its core is the event log, right? All decisions that we made after we went with this kind of fell out from deciding, let's use the event storage as the system of record. If it's the heart and brain of the system, it means that it's the permanent record. Every change to everything we keep forever. I think of it as a ledger. If you think of an old financial record keeping, pre-computer, you have a piece of paper, you write every transaction in pen, not pencil. You can't go in and erase it. Instead, if you make a mistake, you have to add more lines to correct it at the bottom. It always adds up, but you always keep all the changes.
Yeah, so what do these events look like? It's great that we're pulling that into the heart of our application, but what is an event? And we could have multiple talks, multiple weeks of discussion on proper event modeling, but really, for simplicity's sake here, think of your events as the smallest grain action that you want your application to track or you want your users to take. As a simple example, imagine like a manufacturing a car, selling or owning a car. Your event may be you created a new car. You added 4 tires to that car. It's not painted yet, so we painted it red. You really decided you did not like that shade of red, so let's just paint it black. After that, we were driving off of the dealership lot, and a tire popped. So we'll change the front left tire, and then finally we've changed the oil because it was due. So I want to point out here with this example, all this data. We have not only the data of what happened and when it happened, but also the metadata that goes along with it. So who performed this action, who performed this action, when this action was performed, to the date, to the time, and as well, like maybe even why they performed this action. And another thing to point out here, when we decided that we didn't want the car to be red anymore, we didn't go back and get rid of that red event. We made a new event that said, now we paint it black. You can't go back and change history. That's not how time works.
So that's how an event stream works for a single object in a single stream, is what we call them. When you extend that to microservices, you want to have multiple types of streams that are managed by multiple microservices. You would expect each team, each microservice to decide how they want to model their own set of events. So in the case of multiple microservices, multiple streams, we don't want to have microservices writing to each other's streams. I like to say, don't cross the streams. Don't let the water get muddied by having different events coming in from different places. It keeps things much more simple to split them up. Separation of concerns.
Yeah, so now that we have all this data, we have all these events coming through our system, what do we do with them? I mean, most applications, most users, they want to know what the data is like today, which is what you would usually get from your traditional stateful storage, like a SQL database. How this can be performed, how this can be achieved is that each microservice, each consumer of these streams of this data can really build out the state that it cares about, listening to the data that it wants and ignoring any data that it does not. So if we go back to the example of our car, we created our car. In our stateful storage, we show we have a car, no tires, no paint, and it came with oil. Awesome. We added 4 tires to it. Great, we have tires now. We painted it red. Something's red. A little bit later, we didn't like that. We painted it black. We changed it to black. We changed the front left tire when it popped, but all we care about is that there are 4 tires, so there's still 4 tires. And then finally, we changed the oil, so now our date updated to last Thursday. So yeah, one thing I'll point out as well with this is that typically, this data on the left, this event stream, would be lost in a traditional system. You would get, maybe you would know that you have a black car, but maybe you didn't know it was red unless you're storing that somewhere else. Or you don't even know that the tire was changed because you don't care about the particulars of the tires. But if you ever did care about that information, it's now lost in your stateful storage.
So we take this concept of building out a stateful storage through event handling and apply it to microservices too. Each microservice can listen to the streams it's concerned with and then generate a view what we call a materialized view that represents just the data that it needs in nearly real time. So it's no longer bulk nightly transfers. Instead, you've got just the data that you need that's tailor-fit to its purposes, and that solves the communication problem that we talked about earlier.
Yeah, so now we've told you a little bit more about the events and the event log. Let's take a step back and see how this flipped architecture can really help us with those feature requests that we were being asked for initially when we didn't have this event log. So the audit trail. Your event log is literally your audit trail. You can consume that data and spiff it up as you need, but really it is a unchangeable append-only log. Notifications. As soon as an event comes in, a consumer can pick it up and then emit a notification based on that, like on its own time if it needs it. Or we can potentially kick off more actions based on these events that we're picking up. The business intelligence, due to this over-time nature of the event log, we can really build reports to any date and time since we started tracking this information. You can even have process that data however you want. How many times someone performed an action, how many times they did the action and later they removed it. So you could count that like as a mistake or something. You can do a lot with this, forecasting even. Our extra API models, due to being able to process this data as it comes in, when it comes in, we can process it and save it in a read-optimized way so that we don't have to do any data transformation when our users are trying to pull that data out. We can store it in the way that it is going to be retrieved. Machine learning training data. We have this data that is, all of these actions taken against our system that we can feed into training algorithms that can be really used to figure out these issues. And not only that, but the data is structured currently in a way that is already being used by systems. So you don't have to parse logs or figure out kind of a new way. As long as your system can understand this data, it is usable. And finally, batch processing. Due to the asynchronous nature of these event logs, you can just keep pumping things into the event log, and they'll be processed as your microservices or your consumers have those resources to be able to do so. And not on here, but we've talked also about the communication aspect, that now you have decoupled those microservices from having to talk to each other.
Yeah, exactly. So that decoupling helps us build a more resilient system. So not only have we addressed those 6 feature requirements that we were trying to approach, but the larger architectural need of a decoupled system means that you're subscribing to the events of each microservice, but if one of those microservices goes down, it just means it stops issuing events. But any other microservices, there's no cascading failures. Instead, they keep operating as normal. And in fact, when the other microservice comes back up, it can just catch up to any events that it missed and then rejoin the stack. And it helps build a much more resilient system instead of all that interconnected communication between services. Furthermore, using kind of the concept of eventual consistency, the events propagate through the system, through microservices, but that acts as a natural buffer. That way, large changes, large loads on the system can be absorbed more smoothly without bringing the whole thing down for a couple of minutes as everything churns through those events. And that's a good way to make things scalable.
So when should you use this pattern? And really, the answer is it really depends on your use case. I challenge you to think back and look at any projects that you're going to be starting or on your current project. If you have need for these features, for this look at the data over time, a built-in audit trail, or if you think you may need it at any point, or even certain scenarios or certain use cases that we haven't thought about yet, I really encourage you to look into this. But this could be used from anything from making a to-do list all the way to an enterprise application. There are multiple large companies that use event-driven architectures as well.
So we went down that journey and built out our systems, and along the way we picked up on some good tips and pieces of advice that I think can help you if you try to do a similar thing. So the first thing I would recommend is build a common event platform. This event system, event sourcing, is something that every team will need to use, so it really benefits you to invest in shared libraries, shared documentation, shared standards, and anything that you can do to help teams get ramped up quickly.
Using domain-driven design. If you think back to the beginning of this presentation when I mentioned we split up our monolith into multiple microservices, this is the approach we took. It really made sense to split things up, not only in a way that made sense for the application that was easy to split, but also something that made sense for the business. What do the users do? What does the business need? And that can also really inform your events. So what are the actions that need to be taken against the system? That really match what the users are doing.
Another important thing to remember is you can't boil the ocean, right? You need to have small steps towards the success that you want as you change the platform. Start with a new small application or migrate pieces of applications if you can. An important move for us was we knew there would be a lot of stateful systems that we have to integrate with, so we built adapters. So they insisted on the nightly data dump, but we parsed it to look for changes, issued our own events to represent those changes, and that acted as a good bridge to our event-based system.
In full transparency, be ready for challenges. It's not as simple as going from A to B. It's quite the paradigm shift from at least what we and our team was used to, your traditional architecture. So we have challenges with validation, going back to the recommendation of that common platform, really making sure that the data that is going into your event store that is now really the soul of your architecture needs to be clean, needs to be safe from corruption or wrong data being put in there. Challenges with concurrency. If you have multiple users that are reading or multiple systems scaled up that are reading from the same event store, you need to make sure that, especially when those events have a particular order they need to run in, that those are being handled properly. That can be quite the challenge. As well as challenges with governance, especially when you're working with other teams, multiple microservices. Any changes to those events, any changes to that data really needs to be communicated and propagated, because as soon as that data changes, unless your systems are ready for it and it's a non-breaking change, you could make these systems start failing when they're processing these events. Though, since that event log is always there, you can always go back and replay those events once you have made those tweaks to catch up. It's another benefit of the system. And on the other hand, I just wanted to share with you just a small win that we had in the short time that we've been using this architecture. We did a large data migration from our legacy application to our new microservice backend, event-driven backend. And we got a bug report saying, oh, look, this data wasn't migrated properly. So I was able to, in 30 seconds, go in, open the event log, and see, oh no, that data was actually migrated properly. It's just you made a change 2 days after we migrated it, and you just went back to check 2 weeks later and compared it and went, oh, what happened here? So we were able to just shelve that and keep moving, especially when we were in a really busy time. That was extremely helpful.
That's right. Another good story for me was we put in all that time and investment in a new platform, multiple years, but then we had a team join, start a new application. They were able to subscribe to old event feeds and build up their data store and really plug into the whole event architecture in about a month. And that kind of quick turnaround time lets them leverage all the cool features and all the cool platform that we built out, and it really delivers value again and again as new teams join. So what I'd like to say is that you can see how this architecture helps address some of those fundamental problems. It might introduce new challenges, as every paradigm shift does, but hopefully you're inspired by that journey that we took to learn about things, and at the end of the day, you're inspired to go learn some of this yourself or to challenge your own assumptions about what makes good architecture. I'd really like to thank the 40-some Finns who all worked on this project. This isn't just the brainchild of Napo and myself. So big round of applause for those 40 Finns who are in the audience right now and otherwise. Thank you.
Yeah, thank you guys.